This is the third in the series of videos developed from an antenna and propagation presentation I have given to a number of organizations in Southern California. Each video is just a few minutes long and will demonstrate some interesting antenna property or electromagnetic wave phenomenon. These are live demonstrations, not simulations, and can be reproduced at reasonable cost by anyone with a knowledge of electronics. We'll start looking at antennas with a basic quarter wave ground plane. If you are a ham radio licensee, you are familiar with this. This is an easy to build omnidirectional vertically polarized antenna. It consists of a vertical radiating element 1/4 wave long surrounded by 4 rods or wires in the horizontal plane called radials serving as the ground. The length of the vertical quarter wave element is critical. The number and lengths of the surrounding wires or rods that form the ground plane are not critical, but should be at least a quarter wavelength long. A disc of metal makes an excellent ground plane. There are ground plane antenna calculators online that you can use to get the needed dimensions. If the radials are bent down at an angle, the antenna will present a much better match to common 50 ohm coax feed line. Some call the quarter wave ground plane an omnidirectional antenna, meaning that it radiates equally in all directions, which we will see is not at all true. Let's look at the effect of the angle of the radials. The length and number of radials is not critical, but 4 or more is a good start. You may see ground plane diagrams with the radial sticking straight out 90 degrees from the vertical radiating element, but that's not what you want. The following are SWR, standing wave ratio, scans at increasing downward angles, the goal being the smallest SWR number indicating the best match. We'll start with 0 degrees down angle and increasing to 60. There will be a small effect on the resonant frequency as we go, so it's good to do final radiating element trimming when best SWR is reached. 0 degrees on this 1300 MHz ground plane, not great at 2:1 SWR. Noticeably better at 10 degrees. Not bad at a 20 degree bend. This is what we want at 30 degrees. Slightly higher at 40, but perfectly acceptable. Trending up at 50 degrees, notice the increased bandwidth. Even worse at 60 degrees. 30 degree downbend of the radials proves to be the best configuration. Next, let's test this 10 GHz quarter wave ground plane. It's built on a piece of 141 semi-rigid coax terminated in an SMA connector. Let's have a look at this quarter wave 10 GHz ground plane. It should be strongly vertically polarized. And it certainly is, and it's also omnidirectional. Except no radiation is received straight up. So it's not truly omnidirectional. Here is a computer plot of the pattern of a quarter wave ground plane antenna. This is a side view. From the top, the pattern would look more like a donut. The maximum signal is 25 or 30 degrees above the horizon. The positioning of the radials will affect this. You can design antennas and create pattern plots like this using computer programs. Some popular programs are EasyNet and 4NEC2. Here is a practical and effective ground plane installation. It is a ground-mounted ground plane with over 20 random length radials. The radials do not need to be buried. A 10-meter quarter wave long copper pipe is the radiating element. A trimmed stainless steel CB whip will work just as well. Once the radiating element length is trimmed for the best SWR, the radiator is a true quarter wave resonant element, so no matching network, bowline, or tuner is required. Two-way communication with any point on Earth is possible with this antenna. In the next video, we'll move on to the dipole and Yagi antennas.